Thank you for joining us for Steel Underground Tanks, an Introduction in History. My name is Tim O'Toole, and I am the Executive Vice President of the Steel Tank Institute and Steel Plate Fabricators Association. I'd like to introduce you to our presenters. Wayne Geyer, who served as Executive Vice President of STI SPFA for over 30 years. Steve Pollack, STI SPFA's Director of Technical Services. And Joe Menser, STI SPFA's Standards Engineer. Without further ado, Wayne Geyer will kick off our discussion on the history of underground storage tanks.
Thank you, Tim. The history of underground storage tanks goes back quite a few years. Just to get a little better background, oil was discovered back in 1859, and the first code requirements were in 1904, which was the predecessor to the NFPA 30 flammable combustible liquid codes as we know today. 1916, the Steel Tank Institute was formed. The letter you see there with the heading Kewanee Boiler Company is a letter shared by a number of fabricators in the Midwest that decided to form the Steel Tank Institute. Two of those companies are still in existence today and are still members of the Steel Tank Institute. The Chicago Boiler Works, now called the Chicago Boiler Company, in a suburb of Chicago, and Morrison Brothers in Dubuque, Iowa. The American Petroleum Institute formed 3 years after STI, and then the first formation of standards for steel storage tanks storing flammable combustible rules occurred with the UL Underwriters Laboratory 142 standard in 1922. That means we're at 99 years for that standard. And in 1925, the first standard for underground steel storage tanks for flammable combustible liquids was developed in the UL 58 standard. Then you see about 40 years before further standards came upon the scene, and this dealt with corrosion control for underground tanks. 1969, the Steel Tank Institute, through 9 fabricators, formed the STI P3 underground storage tank standard, which we'll be talking about in a little bit. And then 20 years after that, 1 year after EPA promulgated regulations for underground storage tank, UL published their 1746 standard for corrosion protection of underground steel storage tanks. It's also important when we consider the history with the development of standards for underground storage tanks to kind of be aware of some of the other technological developments that were taking place. First, let's kind of go back to why all of a sudden was there the need for storage of petroleum, petrol, fuel oil, gas, whatever you want to call it, in the early 1900s. Lincoln Electric invented the first welding machine in 1907, when we look just at the welding history. And interestingly enough, the Model T that Ford created started in 1908 to 1927, and there were about 15 million of those built. But it's basically a luxury type vehicle that basically the rich could afford. It was not a commodity yet at that point. The welding further developed. The first pipeline got put together in Oklahoma in 1914. The American Welding Society formed in 1919. Various electrodes developed in the 1920s. The boiler and pressure vessel code in 1925. And a real popular weld procedure, submerged arc, 1930. The point of all this is there was welding in the early 1900s, but it really did not advance where it could be used to build production for storage tanks till some 20-some years later, 1930s, 1920s was UL standard. And then there were further developments, as you see there, in the 30s and 40s. So the tanks prior to all the welding were generally riveted, and you see a very granular picture of an actual riveted tank back in the 1920s being carried by horses to its destination. So kind of think back about what I just said with the cars and the automobiles being developed. By 1927, the Model A was created and built from 1927 to 31 by Ford. And this became a much more of a vehicle that the common person could buy and really created the need for bigger production, faster production, which the welding process brought. When I go back in the Steel Tank Institute files, I really don't see a lot of further standardization until the 1950s. And the Midwest 56 standard was a standard built and developed by both the steel tank fabricators and the oil companies. They wanted to standardize the size of the fitting on an underground tank and the location of those fittings so that things like fill lines, vent lines, and so forth could be connected and standardized at the petrol stations that were popping up all over the country at that time after World War II. You can see there that the tank sizes were pretty small by today's standards. Today, we might see underground tanks of 20,000 gallons, 30,000 gallons being put in, with some with compartments. Back then, 2,000 gallon, 4,000 gallon was a popular size. In the 1960s, this was still before environmental movement, the oil companies started experiencing corrosion from steel storage tanks being put in the ground, which did not have corrosion protection. At that same time in the 60s, the oil companies were looking at it more as money out of their pocket, their inventory, and not really as I said before, it wasn't an environmental issue as it is today. So there were a number of efforts being made by the steel tank industry as well as the oil companies to find tanks that could go in the ground that were corrosion resistant. One of those studies was with a non-metallic tank with fiberglass structural tank that Owens Corning was developing. The steel industry experimented with a couple things. One was just a plastic baggie that you can see here in this photo. This photo is in the 60s. You can see the very, very sophisticated joining technique, that duct tape there. This was apparently before OSHA rules were too evident, because that fellow there almost looks like a cigarette in his mouth. Is pretty darn tight between the wall of the excavation and the tank, and the other fellow is laying across the tank. Clearly not acceptable installation standards today. But believe it or not, some of those baggy tanks actually came out of the ground in the 80s and 90s, and where there was not much groundwater around and the tape was sealing that plastic, it did a nice job of providing corrosion protection. Now, those are not too many of them because the tape generally didn't last that long. But there was a company in Michigan in those days, and they actually commercialized and sold a package called Polywrap, or a polyethylene wrap over the tank you see there. There were a couple other systems that the Steel Tank Institute and its members were investigating. One was use of FRP coatings. As I said before, Owens Corning was developing a fiberglass tank, and the steel industry thought, well, maybe we can use that FRP, fiberglass reinforced plastic, as a coating. This was actually a standard developed by STI called StyLife back in 1968, and it was actually the first technology where STI had a labeling system that was applied on the tank. You can see there that the demonstration with a sledgehammer to show that coating was pretty tough. And some fabricators stuck with the fiberglassing for the next couple decades before a new standard came out called the Act 100. But putting a fiberglass coated tank together was not easy. There was a lot of hand-applied requirements. The aesthetics weren't necessarily great, and the cost was great. So one other system that was being tested was a cathodically protected system. And this system was called the STI P3, where P stood for the word proven protection in three ways. The three ways were through a dielectric coating, a magnesium anode, and separation between the steel tank and steel pipe through something like a nylon bushing, where the steel pipe and steel tank didn't touch one another. I talked about the development of welding through the years. One of the big advancements that allowed the STI P3 tank to become successful was with coatings. Up until this time, underground tanks were just coated with like a primer, asphaltum coating that was basically to prevent the tank from corroding while it was being shipped or stored in the yard or stored at the job site before it went in the ground. People didn't really understand that groundwater and soil could have a corrosive effect on steel. As coatings progressed, that soon got replaced with the STI P3, which necessitated the use of a high-tech coating at that point called coal tar epoxy. Later, that coal tar epoxy became replaced by another coating in the early 80s called polyurethane, which was a much more productive tank coating to be applied because it could be applied and cured in an hour, where coal tar epoxy took maybe a day for it to harden up, and there were also some solvents in it. You see here the STIP-3 tank was being shown to some potential buyers who were learning how a steel tank could be prevented from corrosion through this great system called the STIP-3. At that time, a standard was created in 1969 with the first tanks in 1970. As I said before, 9 companies and 9 fabricators started promoting it. The oil companies wanted a national effort on this, so the Steel Tank Institute agreed to take it over, apply a 20-year warranty to it as requested by the oil companies. And the system had a labeling process and an inspection process, which STI did to verify the tank met the standard. You'll see some more pictures here, and rather than myself go into detail, I'm going to turn this over to Steve Pollock, the Director of Technical Services for Steel Tank Institute.
Thank you so much, Wayne. I appreciate the history leading up to these tanks. And what I'll talk about from here on is a bit about what you mentioned, the 1988 promulgated federal regulations and the designs that go in to meet these. As Wayne mentioned, the tank construction was modernized, coatings became modernized. This slide lets you know that, again, you're looking at the 3 ways of protection there. There's a coating on the tank, there's sacrificial anodes, and you can see the installation of a nylon bushing into the top fittings. Those are important for making sure that any of the other tank appurtenances on top do not short out the tank and basically have the sacrificial anode trying to protect more steel if somebody connects a steel vent pipe or previously steel piping or is connected to a submersible pump. So the nylon bushings are a very important part of that isolation. More innovations were encountered over the years, and we're very proud of what we worked on. In 1979, cathodic protection test stations were developed. You may have come across these out in the field and heard references to PP3 or PP4 test stations. The idea was to make the testing simpler for owners, even with the voltmeter and having that connection to the steel of the tank and a buried reference cell. Wayne had mentioned the urethane coatings. Those came on in 1981 and were an important aspect of improving on our coating systems. One of the things that did come about based on installer experience was that it became important to weld the anodes onto the tanks. The anodes used to be shipped separately, and part of the installation instructions required that the person in the field had to wire the tanks on, attach the anodes onto the tanks, and that was not being done consistently. So we decided that welding the anodes on was a better development. 1984, we also looked at dual wall technology, and double wall tanks with interstitial monitoring was developed. And Wayne mentioned another coating development too. We did look at FRP coatings on these tanks. So as secondary containment, as that was developed, and of course now we know that secondary containment is the rule of the land based on the 2005 Energy Act and the regulations that were promulgated in 2015, but double-walled tanks have been around for a long time. In 1981, Type 2 double-walled tanks were being built. These were the tanks that were intended to hold 110% of the capacity of the primary tank within the secondary tank. The tank construction was very expensive, partly because it used a lot of steel. And the idea behind, if you hear the phrase Type 2, it means that there was standoff panels between the primary and the secondary that basically provided inches of interstitial space between the primary tank and the secondary tank. Europe had been working with a technique that was more of 100% containment instead of 110, and was an intimate marriage of the secondary wall to the primary wall. The Type 1 tanks came in through and were adopted in the mid-80s. In 1984, we were working with a Type 1 dual wall wrap tank, and that fits STI standard as well as UL standards. In the late 80s, of course, we started working with jacketed tanks, and that became part of what we work with more now. We'll look at that at the next slide. One of the other components that we looked at in the mid-80s as a unique addition to these tanks was fitting all of the fittings into one containment sump. And you can see there's a P3 tank with a collar around all the fittings, and what you might not be able to see is that collar is coated. And of course, the rest of that containment sump has to come up to grade. Again, we're talking about preventing corrosion with coatings and anodes and with isolation. So to complete that containment sump up to grade, we still had to include an isolation around that collar and isolating link seals to connect what would be the rest of a steel sump all the way up to the top of the grade of the tank. Now, plastic sumps and fiberglass sumps came out a little bit later. These steel containment sumps were obviously heavy and hard to work with. You probably won't run into these very often, but that was one of the unique innovations that we looked at in the mid-80s. One of the questions that comes up from regulators, and I actually used to ask this question when I was a regulator, was when were the first composite tanks? Wayne showed you pictures of some of the original attempts with Stylife, and that they were fiberglass coated tanks back in the late 60s. And technically, you could call that a composite tank. The formal notion of a composite tank came with manufacturers who developed the Association of Composite Tanks and developed what we know as the Act 100 tank. Most of those members of ACT were also Steel Tank Institute members. And after that, the ACT FRP clad tank was developed formally in 1987. STI took over that technology in 1990, and the Act 100 tanks are still produced today. So in 1991, the next development was an FRP jacketed tank. You may see these as our PermaTank technology. Again, this is a tank that, even though it's from 1990s, is acceptable even now as our secondary containment rules take place across the nation. This is a steel tank with a close to intimate wrap fiberglass material sprayed on, and that allows for interstitial monitoring of the interstitial space. And this has been one of our more successful tanks and produced across the nation and the world. Our standards engineer, Joe Menser, is going to talk about above ground storage tanks in the next session.
Thank you, Steve. We've been discussing underground tanks, and we can also include above ground tanks in this discussion. Above ground tanks actually predate the underground units. However, they were limited in use due to regulations that require them to be separated from people's residences, and also the requirements to provide containment caused problems. But in the early 1990s, some design options became available that addressed those. One of those was the creation of a double wall tank using similar technology as with the underground tank, but that double wall tank system provided the necessary secondary containment for the tank system. And then the next one was the introduction of insulated tanks, or tanks that had an insulation system incorporated in them that allowed them to be placed closer to people or businesses because the tanks could withstand some minimal exposure to heat. This increased opportunities to use above ground tanks, and there was sort of a feeling among industry to get away from some underground tanks due to some earlier problems. And as we move on into the future, we're finding things like tanks are getting bigger. That tank there, I believe, is an underground tank, about 50,000 gallons. They don't get much bigger than that. Above ground tanks, the shop built units can actually be built up to 75,000 gallons. We've seen the introduction of compartmentalized tanks. That's where a common shell holds multiple smaller tank units so that just one tank unit can store multiple products in multiple sizes. It makes installation more convenient and operation easier, and reduces the amount of equipment. That can be done with both above ground and underground units. The double wall design addresses the secondary containment requirements for the underground tanks. Steve mentioned there are federal laws that require those. Likewise, for above ground tanks, the federal code called the SPCC standard requires secondary containment for storage tanks. We've learned over the years too that steel tanks especially have excellent compatibility with biofuels and the new fuels being introduced. History has shown that steel can hold up fairly well to all of the materials that people have included in motor fuels. And we've also learned over the years, proper tank maintenance means tanks that operate as the owners want them to and operate reliably and safely store the product that's in them so that it's available when needed. For issues of discussion, these are things that often come up when we talk to people about tanks. And let me just hit them briefly. But if you're looking for information, you can certainly go to our website, www.steeltank.com, and there's information on all of these. For water in tanks, water is the enemy of fuel storage. So care must be taken in design and operation to keep water out of the tanks. We do have advice on how to control and manage water. There are methods available to remove water if it's found, and through proper design and maintenance, it shouldn't get there in the first place. Bear in mind that water will damage both the product and the tank if it remains, but it can be managed if an effort is made. For tank repairs, one of the great aspects of the steel tank construction is that it is repairable, it is modifiable. We do have standards that address those as well, and those are available on our website. But steel tanks, they can be repaired or they can be even slightly modified if called upon. For lining in steel and fiberglass lined tanks, there are options available, especially if water continues to be a problem or if the tank is used or stores product that isn't used regularly, like an emergency backup generator. And likewise, when people store other chemicals in tanks. But if you need some help with linings, again, we can help you with that. As far as tank life goes, steel tanks have been in operation, especially above ground, since the turn of the century. I can point to tanks built in the 1930s that are still in operation today. Those are above ground tanks. But even the underground tanks, when they're properly maintained and properly operated, they've operated 30 years successfully, and we don't see an end to their life as of yet. Finally, if you have any questions, here's the contact information for the Steel Tank Institute members. Please feel free to contact us with any questions you have. We'd be happy to help you out.